Hello guys, and today we will talk about the electrolysis of molten compounds or electrolysis of the salts. So on the example of the sodium chloride salt, I will try to explain the topic of the electrolysis and explain why it's essential to know the principle, how we can use it in the real life, and why we do study it on our lessons. So sodium chloride, it's a common chemical compound that formed by combination of the two elements. It's sodium metal and chlorine gas nonmetal. The question here, why does this reaction between sodium and chlorine occur by itself in the nature? The point here that sodium is a metal located in the group 1. There will be one valence electron on the last shell. And in order to achieve stable electronic configuration, sodium tends to lose this electron. So, and after sodium will lose electron, it will reach electronic configuration of neon, so it will become highly stable. While chlorine has 7 electrons on the outermost shell, and they are 1 electron required in order to reach electronic configuration of the argon, in order just to become highly stable. So both of them will reach electronic configuration of the noble gases, reach octet. They are both happy. However, after sodium donated 1 electron, there will be positive charge on the sodium because there are more protons in the nucleus than electrons. And chlorine will accept electron, that's why there will be more electrons, so it will become negative. And between them, there will be attraction between positive and negative ions. So that's how ionic bond formed. And the question, what is electrolysis? Electrolysis, it's a process that will allow us just to separate these ions in order just to form again pure elements. And how we can do it, we will just discuss. So let's move to the electrolysis process. All right, in the world of electrolysis and molten compounds, here's a deal. We have got to get that salt all nice in liquefied before we dive into the process. You see, the ions inside that molten compound need to be able to move freely for this whole electrolysis magic to work. Let's draw the equation. So sodium chloride will melt and ions in the liquid form will form. So you will observe formation of the sodium and chlorine ions that can freely move in the liquid forms. So first, we heat up the salt until it's turned into a liquid in our trusty crucible. And here where the fun begins. We need a pair of electrodes, but not just any electrode. They have got to be made of inert material, so they won't to go melt or reacting during the process. These electrodes are our electrical connectors, and they are hooked up to a source of electrical current. Once you flip the switch and power it up, it's like starting an electron pumping engine. The electrode that you connected to the negative side is called cathode. It's like a magnet for those positively charged sodium cation in the liquid salt. On the flip side, the electrode connected to the positive end, and it's anode. And it's all about attracting those negatively charged chlorine ions. Let me try to explain using the ionic equation. At the cathode, you expect that formation of pure sodium metal, and anode, formation of pure chlorine gas. So chlorine will lose electrons, and there are 2 chlorine ions that will donate 2 electrons. This electron will move through the circuit, where on the cathode, sodium ion will accept them. Sodium will gain this electron, and since the number of donated and accepted electrons should be the same, here in the half equation we need to balance it. But 2 electrons will be donated by chlorine ions and 2 electrons will be accepted. And here you can write the full ionic equation. So ions will exchange with the electrons to form pure zero-state elements. So on the cathode, you will expect formation of the pure metal, and on the anode, pure chlorine gas. And on the anode, it will be like green gas. On the cathode, it will be metallic deposition. So guys, this process usually takes place in the reverse direction. So sodium react with the chlorine in order just to create like stable electronic configuration, but we have a chemical method in order just to create pure metal again. So this method often used in order just to produce pure metals from their ores, and we will discuss this process. Thank you very much for your attention.